Hello, assalamu alaikum, and good evening to all our respected faculty members, researchers, students, also the upcoming passionate engineers. Hope every one of us are at the best of our health in this diverse situation of the pandemic. I, Tazwar, from the Department of IEEE Independent University Bangladesh, would like to welcome you all in the most awaited and exciting workshop on PCB designing organized by IEEE Industrial Application Society, IUB, Student Branch Chapter, and IEEE IUB Student Branch, which will be taken by our very own, one of the most efficient pupil of our institution, Mr. Nazmus Sakib. Now I would like to request Professor Dr. Abdul Razak sir to share some few words with us.
Okay, so thank you, Tajwar. So I'd like to welcome all the participants to this workshop. So basically, this will be a very interesting workshop, as I can see that the title is PCB Design using Proteus, right?
Yes, sir.
Okay. And the trainer is also very experienced on this topic, Nazmus Sakib, who was actually graduated from IUB and is now the graduate student and also the graduate research assistant of IEEE Department of IUB. And I hope you guys can enjoy. And of course, this is the getting started. For those who are very learner stage. So don't stop here. We just proceed from here, and it just practice on it. So basically, you know that this is the one of the softwares by which you can actually design the PCB, and for the electrical, electronic, telecommunications, or even the computer engineers, the PCB are the one of the most important thing to design. And I hope this will be very interesting. And I also learned from a student. This is my 26 years of my teaching actually. So 25 years gone, not my age, but the teaching age. So you can see that still I'm learning from my students. So learning is actually from birth to death. So those who actually want to learn, there is no age. So that's why at this age, even I learn from my students. A lot of things, of course, students learn from me in the class, but outside the class, a lot of things actually sometimes need to learn and enjoy. And I'd like to thank IEEE Industry Application Society IUB Student Branch Chapter to organize this kind of workshop, and hopefully you guys can continue. And as an advisor of this society chapter at IUB, I am always helpful and cooperative to this kind of workshops. And I hope this will be very successful workshop, so you guys can enjoy. Okay, so thank you very much, Tajwar, and I'd like to thank all the EXCOM members of IAS, and also not but the least, of course, our trainer today, Nazmus Sakib. So thank you very much. I wish a very successful workshop.
Thank you, sir. Thank you for your wonderful speech. Now we also have with us the Associate Professor MD Kafil Islam, sir. Sir, if you could just share some few words with us.
Assalamu alaikum. Thank you, Tazwar, and thank you, Rajak sir, for your nice speech. So I think better to start. It's already 15 minutes late, so I'd like the trainer Nazmus Sakib to kindly start the workshop. And Tazwar, over to you. Thank you.
Thank you, sir. Sir, before we start, we'd like to know more about our trainer. Mr. Nazmus Sakib had completed his BSc in IEEE from IUB and now pursuing MSc in IEEE at IUB. He has worked as undergraduate research assistant before and now working as graduate research assistant under the supervision of our beloved branch counselor, Associate Professor Dr. M.D. Kafil Islam, sir. He has worked in several research projects both with Professor Khosru sir and Associate Professor Dr. M.D. Kafil Islam, sir. So just to give a general idea before we start, printed circuit board design brings our electrical circuits to life in the physical form. Using layout software, the PCB design process combines component placement and routing to define electrical connectivity on a manufactured circuit board. Therefore, to design this PCB, there are some popular softwares like PCB Web Designer, Zenith PCB, TinyCAD, KeyCAD, and FreeSync, Proteus, etc. So, Nazmus Sakib, sir, a simple question will arise today in everyone's mind that why are we using Proteus rather than any other software? And we hope you will be proceeding to answering this question, or we will get the answer throughout your session. In the meantime, I would like to request all the participants to write their questions in the chat box while the session is going on, which we will go through after the workshop. So the floor is all yours, Mr. Nazmus Sakib, sir.
Yes. Hello, everyone, and thank you very much for the introduction. It was very good. I didn't know. Okay, so let's begin. The first question you have asked me that why are we using Proteus instead of the other softwares? First of all, we are using Proteus because the Proteus software is one of our course in one of our course curriculums. We use this software in many courses, as we know. Our embedded system course is completely based on this software. So what we do here is we can do many things with this software, like we can simulate a circuit, we can design it. So everything is included in a single software. So it's very easy to use. As I go through everything, you guys will understand it very easily. It's just like a game, and you will enjoy using Proteus more, I think, rather than any other software. In CAD and other softwares, it's also easy, but Proteus is a kind of a user-friendly software where you can design a design a circuit, and also design its PCB to make it in a real form. So let's start. Okay. Then I believe everyone here has the software is installed, so I will not waste any time to showing you how to install this software. You guys can use their various YouTube videos to how to install this Proteus software. So let's begin. So this is basically the Proteus software where you can, in the beginning, you can see the screen. So first of all, we'll start from the beginning. As you all might know that this software is not free. Basically, we use the cracked version of this software, and you can see here my license is till 2031 for the cracked version which I'm using. So let's begin. So first of all, what I want you guys to do to open a new project. So for opening a new project, you can click here for new project or open a project or new project. To access the previous project you have worked, you can select open project, or recent projects are shown here. So as we are going to for a new project, we'll select the new project. So then this window will pop up, and what I want you guys to do is rename the project as it's always will show new project. So let's write new PCB. Okay, then let everything be default as it's selected. So I just next, then next, finish. So this window will come. Now, as we want to work on a new circuit, so I thought that we should go start from a beginning. From a simple circuit, we'll go to the advanced circuitry. So first, let's start with a simple RLC circuit, or just a circuit with an LED. So first, what we'll need is a resistor. So this is the component section. By clicking here, you will be able to select components which are you have selected from its library. To find the components which you need to click here, the P, after clicking here, parts. So after clicking here, you have to write down the name of the part you are going to use. Like for example, resistor. Yes. After typing, there are multiple resistors. You have to understand which of the component you need to use in your circuit. So as you can see, there are several components, like thousands of components. thousands of resistors available, but which one you need for your circuitry is up to you. So what we'll use, that we'll use the um, basic resistors, which we use in regular basis in breadboards, and we can see them in other components. Here the PCB layout is also given for this particular resistor. So you can see the spacing between the two holes is 0.4 inch, which is for a quarter watt resistors. Any quarter watt resistors distance is 1.4 inch. So it's compatible with any PC. We can use it for any circuitry. So let's select it. By double clicking it, you can see that it will pop up here where your devices are listed. Then what we need is a LED. So here you can see that there are many components, but we need an actual LED to work with it. So let's see. So you will often find this problem that there are no layouts, PCB layouts given for an LED, but you can use them for simulating your circuit. So let's select any LED. Let's take a blue one. Okay. Then for now we'll use only these two. Select OK. Now what you have to do is you have to place those components. First you need to select here which component you are going to place. Then coming up here in this open page, in this blank page, you need to right click. See? Sorry, left click. I often got confused with the right click or the left click. So you have to left click here and place it here after again clicking it. Then you need the LED, of course. Here is the LED. Now it's looks like our circuit is almost done, but now we need to connect it with when we need a battery. For DC source or any AC source, you need to click here. Here is a symbol of sine wave. You can see here are all the generators placed, like DC, sine, pulse, or any other kind of signal you want to generate for your circuit. We need a DC source, so we'll place a DC source here. Now we need a ground to complete our circuit. So for the ground connection, we'll click here, terminals, and then go to ground. Terminal, then ground. Then place the ground here by right clicking it. You have to first right click to make the component appear here. As you can see, it has been appeared. Then you need to place it again by right clicking it. And if you want to make it go away, just click it again or press escape. Now what I want you to do is to connect them with wires. So for that, as you can see, there is a pencil already appeared in the window. After pressing escape, you see this pencil will appear. Now what I want to do is to connect this one with this resistor, the DC source with the resistor. So just first left click once. You don't have to press hold it, you just have to click it once, and then you see that you wherever you take it until you press again, it will move around. So we need to place it here, then again left click. Done. Next we need to complete the circuit. So again, this end of the resistor goes to the positive end of the LED, and the ground, as you can see, this symbol shows the negative side of the LED will go to the ground. So far I don't think anyone has any question, and this is a very basic part, and whoever has used PCB knows all about this, but just to be sure, I'm trying for the new ones, I'm trying to explain all this. So it's completed. Now what we have to do is we have to edit the values. As you can see, there are no value for given for the DC supply. So we need to double click here and change the value. Just we need 5 volt or 9 volt, whatever you want. You can even change the type of source you are using. You can change it from DC to sine or to any PWM signal or anything else. So let's stick with DC and give it a 5 volt DC and click OK. So now it's a 5 volt DC, and this resistor is 10 kilo ohm, which is a very high. So we'll change it again by double clicking it. Will this window will pop up, and then you can do is you can change the resistor name and also the value of the resistance. So let's give it 120 ohm. You just write 120, it will change automatically change into 120 ohm resistor. Then we'll rename it like just the single resistance or the star. Okay. So now to simulate this circuit, what we'll do is we press here, a play button is over here. We'll just click it play. Okay. What? See? So the voltage we have given to this circuit was not enough to light up the LEDs. We had to increase the voltage. So this is some of the real life thing you will always face, that the source you are using is not enough. You can always simulate it in Proteus to find out what could be the problem in your circuit. Next, this is a very simple circuit, but what we want to do is we want to make it a bit complicated circuit for our PCB, because this circuit is not worthy for a PCB. So what I believe everyone from IUB has done the electronics too, and quite familiar with the uh, component called op-amp OP741. You can unmute your E and can say if anyone knows about it or not. Okay, so what we are going to do is we will try to make a simple op-amp based circuit and try to make its PCB as well. So that will be the beginning. This circuit was to just to understand how to get the components, how to place them, how to connect them. And now what we'll do is we'll make a circuit. You can open a new project or edit this project to work with it. So if you want to make everything go, just control select everything, then press delete, everything will be gone. Now we want to what I want to make is an let's make a light detecting circuit, a circuit that will turn on when the light is off or the light is on, will give us some kind of indication for because of the light turning on of the light. So for that what we need is an LDR called light detecting resistance, which resistance increases or decreases depending on the light. So here again we'll go to the parts. Here you can see there is a symbol here. Then go to parts, select right LDR. Okay, this is the LDR. So you want to select this one with a torch, the light depending resistance. So you have to write light. You just can't use it short form to make it appear. So light dependent resistance. So we'll use this one, the active one, torch LDR. Torch LDR. So then we need an op-amp 741. So write 741 here. You can see that 741 appeared with its schematics of the PCB layout. So double click, then it will appear in your workplace. Next, what else we need? We have an LED, some resistance, and on op-amp. I think we're good to go. Okay. So this is just a simple comparative circuit. So what it does is it compares if the resistance is low and one end or high. So from the simple comparative circuit, we can make a light detecting circuit. First, you need to place the op amp. Select the op amp here, 741. Then left click once, twice to place it. It has been placed. Now, what we need is we need to give it some kind of power supply. As you can know that pin number 7 is for the power, and the 4 is for the negative power or ground. So we'll go to the generator, select a DC source, place it here. Then we'll go to the terminals, select ground, place it here. Then connect 4 to the ground and number 7 to the DC generator. Next, we'll select the DC generator, make it a 9 volt, as we all use. Maximum of you will use the 9 volt battery for this kind of project. Then we'll go to the components, place all the components here. For first, we need 4 resistors. What I'm going to do is let me show you the circuit first. Then it will be easy for you to understand what we are making. So this is the kind of circuit we're going to work on. See, a simple circuit. Here, this is the LDR. There are 4 resistors, 1 for the LED and 3 for the comparator. So let's go to our circuit. So let's place first of all 4 resistors. 1, 2, 3, and 4th one is here. Then the LDR, let's place it here. Then the LED, blue LED, which you have used. Okay. So you can select the component and change its place or its current shape. Like you can rotate it clockwise or anti-clockwise, however you see fit. So let's rotate this one. Place it here. Let's connect them. Okay. Now let's connect this end with this two end to positive side of the circuit and this end to their negative side. Now let's connect this 2 point and this 2 point. Now what I want to do is I want to connect this end with the positive side, as in the power supply side, and this one to the ground. So our comparing side is ready. Now we need to complete it, the circuit from at this side. Here we need to connect it here. Then this one, the negative part, goes to the ground. This is again a 10 kilo ohm resistance. We need to change the value of this resistor. So let's make it 120 volt, 120 ohm. Place OK. Okay. Now this circuit is completed. Let's try and see if it works or not. As you can see, there is no light. The LED is turned on. If we bring the light closer, it will turn off. So this is a simple light detecting circuit, which will glow. The light will glow in dark, and light will be turned off if the light appears. Now let's make a PCB for this simple circuit. Now, before starting the PCB, there are few issues in Proteus which you will always found that if you are trying to simulate a project in a particular version of Proteus, you can't edit it in another version of this software. Sometimes it will give you trouble. So it's best to use the version which will be instructed by your instructor when you are doing the course for the Proteus or any other course where you are suggested to use Proteus. Because if you are using an 8.7 version, you won't be able to simulate the same circuit in a 7 version or a higher version, or even you cannot even access the PCB layout of that circuit in any other version. So in this version, even in different versions, the positions of the quick access buttons are not in the same position. For most, and in IUB mostly we use this 8.6 version, so I'm using this 8.6 version, and you can also use this 8.6 or any advanced version if you want to. But most of all, everything is same, just accessing the files can be difficult for you if you are using a different version. So now what we want to do is we want to make a PCB. For that, we'll go here, a PCB layout. From here you can see there is a IC icon here at the bar. Just by clicking it, a new window will pop up here, the new window. This one is the schematics, and this is a PCB layout where you are going to work with the circuit you have just drawn. You want to make the PCB. To make the PCB, what you have to do is you need to make a border for the circuit. The border can be big or small depending on the size of your circuit. So first you select here border edge, then select here, first select here, then select border edge, the yellow one. So if you want to make your circuit roundish or a box shape, it's completely up to you to select which shape you want to give to your PCB. So let's make a square PCB. So first we'll take a dimension, any dimension, then we can edit the properties to change its dimension. Next, again here, components mode. There, as you can see, this LED is showing cross because it doesn't have any PCB layout. So what you have to do is you have to manually make a layout for this PCB. This is one of the problem you will face, that sometimes not all the layouts of your components will be available, but you can simulate them, but they don't have any schematics for the PCB layout for that component. For that, you have to make your layout by yourself. So let's play all of the layouts which are available. Firstly, the LDR here, then the resistors, one, then right click to click here. As you can see, it seems that all the components won't fit here, so let's left click here and then increase the dimension. By double clicking it, this window will appear and you can change the dimension manually just by writing the value of the dimension, or you can increase it just by selecting it. And okay, so then actually if you guys are asking me question, I cannot see the window for the math text, so you can unmute your mic and can ask me question during this session. I won't mind, but just one at a time. Don't everyone just don't rush at me. I won't be able to understand. So next, select the 741 IC. Yes.
Yes.
Hello. কারো কারো কোয়েশ্চেন আছে?
Sir, I feel that this will consume time. After the workshop, we could go through all the questions at a time.
ওকে, তাহলে যদি থাকে খুবই কোয়েশ্চেন থাকে তাহলে প্লিজ সামন জাস্ট আমাকে জাস্ট আনমিউট করে বলবা যে একটা সিরিয়াস কোয়েশ্চেন আছে বা কিছু একটা, বিকজ আই ডোন্ট থিঙ্ক যে সবাই যদি বুঝতে না পারে দেন ওয়ার্কশপটার মানেই হবে না। Okay, let's select the 741 IC, then place it here. Next, another is so let's select it here, then left click, place it here. There are some as you can say, there are some facilities given to this software that you don't have to uh, wire create the wire by yourself or wire this complete circuit by yourself. There are some sections called auto routing, so where the wires will be automatically connected for you and the components will be automatically placed for you, but that won't help in terms of your project because you won't be able to select the placement or select the wire length, wire dimension by yourself. It will be selected by the software, so I don't recommend using that. And there are few things you need to understand that in Bangladesh or in any other country there are few problems where while designing a PCB. It's the availability of the resources we have that makes our PCB. So in Bangladesh, the resources we have won't be able to make a very complicated PCB like with a very thin copper line. The copper lines are which the circuits are connected with. So if you select a very thin copper line, it won't, the resources we have in our country won't be able to make the workshops where you will give your PCB design won't be able to make your circuit with a very thin or a very unreliable circuit. So you need to make, you have your choices will be upon those. There are several layer PCB like this PCB can be done in a single layer where the coppers will be only one in one side. There are circuits which has copper on both sides. That's the two layers PCB. In Arduino or any other circuit boards, you can see that there are lines drawn in both sides of the PCB board. But sometimes it's not required you to make it a two-layer PCB because it will be a expensive one. At the same time, if you make your PCB bigger, as this age is very bigger, so per square inch of this PCB will cost you even more money. So try to make your PCB smaller, try to make those lines clear so that you can draw them and the machine here can make your PCB correctly. So I hope you guys understand that. Now let's wire this PCB. So first we need to place the components to our requirement. For that you need to select the mouse here. Here you can see this icon. Then select the component you want to change the place. Then change its place from here or anywhere you want to. Then change it here. The green line shows that where it will be connected, where the line, where this end will be connected to. As you can see, when I remove it and I move it, it shows that this one, sorry, this one will be connected here. This line will be connected here, here, and here. And this line will be connected here and here. So we don't want any line to cross each other. So let's see which lines will cross each other, then we'll change its placement accordingly. Firstly, you have to select this wire, the track mode. Select the track mode, then select your required line's length. This is the thickness of your wire. If you select a very thin wire, it might not work for your circuit, and if you select a very thick wire, then it sometimes it's very completely unnecessarily. And when you are trying to order a PCB or sending someone your design, there will be some requirements given that you can't use your line as lower than T30 or as lower than T50. So you have to change your design accordingly, because you won't be able to have that design ready if you don't follow the requirements. So for any part signal, it doesn't matter how thick or thin the wire is. Just for a signal, there are very few milliamperes who current will pass, so it won't damage the track. But if you're working with a power circuit where you are working with hundreds of amperes of current, it will damage your track if you have a very small track line. So we'll use here T30, track 30. This is track 40 if it goes on. And again, the current capacity, and the important thing is the current, how much will the track will carry the current. Again, it's not determined by the 30 millimeter or 40 millimeter or whatever this T30 is. It depends on many things like the thickness of the copper track or how thin they are. So you can't say that I need a 10 track to carry 10 ampere and these 400 or 200 will do the job. It's not necessarily. You have to, sometimes you have to test it out to find out which one will work the best. For as the circuit won't you consume much power, we'll use the T30. So select T30. You can make it default. You can make T30 the default circuit or any other one. So let's connect here. After selecting it here, then we'll connect the wires. As you see, when you first click it here, it will show the arrow where the wire should go first. So follow their guideline and connect it here. So one line is connected. Next, right click here, left click here, then again click here. So the other line is also connected. Next, this one connected. Click here, then click here. Okay, this line is also connected. Now let's click here and here. Now this one needs to be connected as well. This one is also need to be connected. Okay. Now you have to connect this one, but as you can see, I have already drawn a line from here, so I can't go from here to here. Now I need to change the dimension of change the position of the components in order to make this connection happen. So what I want to do is I'll select the mouse again, select it here, then you can move it or you can delete it. Firstly, we'll delete this component and see where placing it won't harm any other connection. So then we'll try to place it, select the component, place the component. See, this position also doesn't help us that much. This one might do. So let's see. Now we need to change its position here. So now you can see that this position will help us to connect the components without causing any kind of short circuiting. So select the track, select 30, T30, track 30, then connect this one, then connect this one. If you have any error while connecting the components, there will be an error shown here. As you can see, they're saying there no error, so that means that it's okay. Then last one is connected here. Now our circuit is connecting, is routing is completed, placement is done. Now let's see how it looks. So in order to see how the component looks after placing the components, you can see the 3D version of the PCB. So here you can see the 3D visualization. You can click here, and then can see the 3D version of the circuit. As you can see, the placement is very unorganized, as there are very empty spaces which are not necessary for the circuit. So what we'll try to do next is try to make this circuit more compact and small as possible. So for that, select the mouse, then by selecting the components, you can change the placement. You can see there are errors. Select wires. See, by changing the position, there are many errors occurred. So how will you change those errors? To change those errors, you have to move the wire or delete the wire and reroute it again. So best thing would be for you to do is place the components to their exactly required places before routing. It will save you time. At the same time, it will also be easy for you. So let's change its place. Change his place. Oh, you can use Control Z to undo anything you have done. So this one. So let's read out this thing again. So let's make this here. This one will go here. This excess wire, you can right click it and delete it. Then you have to go through this one to avoid any cross connection. This one will be connected here. This one will be connected here. This one will be connected here. So now let's see the 3D visualization. See, it has been placed too closely to complete the circuit. Next, you need to reduce the size. Select the mouse again, select the dimension, and reduce it to your requirements. Now you can see that one component was missing, which was the LED. You need to manually make a layout for the LED without causing any kind of cross connection or any kind of error. For that, what we will do is we need to select pad holes for the LED. For that, we need to know few things: the placement of the hole size of LED to and the spacing before between the two holes. Like for this one, we knew that we need 0.1 inch of spacing, which was already given by them. Now for our LED, how much spacing we need between these two holes? So that is up to you to find out, and you can use the ruler here in dimension mode. You can see here is the dimension mode. You can see the spacing between two holes or any dimension you have just made. Like here we need to know the dimension of the, okay, so just draw a line across. It's a 34 millimeter by 34 millimeter by 34 millimeter square. So it's a 34 millimeter by 34 millimeter box. Now we need to make the LED, and let's just assume that space between this hole of the LDR is same as the space between the an LED and basic LED. So let's find out the spacing is 3.81 millimeter. So we need to place two holes, pad holes, in spacing of 3.81 millimeters. So first select any pad holes you require. Let's select a square one. Now, as you can see, it shows, the purple one shows the part where you are going to use your lead to connect the component, and the hole is the one where the drill will be. So the hole size and the pad size, the rest of the size are also given here. So so you need to understand which hole will be suitable for the LED to insert. So let's use these 60-30. So the complete die 60 TH by 60 TH, and the hole is 30 TH. I'm not sure of what's the TH gives. I think it's below millimeter TH size. So let's place two holes here. If you want to make it disappear, just right click and it will be disappeared. Now let's connect those wires. So where do we need to connect them? So let's go to our schematics and see where the LEDs are connected. The LED is connected in between a ground pin and this pin, the 120 resistance other end. So we can see this end is empty and we need to connect the other point in any other ground. So you can see this is the ground connection. Here it's written the ground. So what we can do is we can just route this one here to the ground. It will sometimes show you errors because you are manually making this more than just connected. Okay, so you have manually connected this one to the ground. Now this one has to be connected here. As you can see that it will be very difficult for us to connect this hole with this hole. So we have to change the placement. We can just rotate it 180 degree. It will change it. Delete this route. Then again the wire track. Then connect this track here and this one here. So now let's see this two new holes appeared are for the LED. Now let's see the placement, if the spacing is enough for an LED to insert or not. It's 4 millimeters, so it's close to 3.81 millimeters, so we can let it be because as we can change it. So now there are few things you have to see, that the track, if you need to make this track more thicker or thinner, or these pads are enough for you, for your op-amp to sit on or not, you can change those pads as well. As you can see, these holes are seems very small for your lead, or while you're giving lead to this pads, they are very small, so you can change the pad size or track size. To change the track size, what you need to do is you need to select the mouse, left click, right click here, then change the pad size. Let's make it 25. It will be smaller. Then if you want it a bit thicker, then just make it 40. So it will be up to you and your applications that which one of them is required for you. Because sometimes the track is not enough to carry out the current for your circuit, for your application. So let's see the 3D version visualization. Here you can see that still we can make this circuit smaller by making those components come closer, more closer. So far, do you have any kind of questions? Okay, is it possible to control the intensity or the wavelength of the light in this simulation? Of course, it can be. It's possible, but the intensity will change according to your resistance. Of course, if you change the resistance, then the light will be dimmer or brighter. But it can burn out if you don't use any resistance. So it will be constant if you don't. But to change the intensity, I think in this circuit it's not possible without changing the resistance, but it's possible if you change the resistance. And any other question regarding this design of this PCB?
Sir, if you may, can I ask one?
Yes, yeah, of course.
Sir, how are you managing the spacing of the components?
So how are we? What do you mean by placing?
Like, is it fixed, or is it like doing the requirements, or is it like up to us?
It's up to you actually, because the placement where you want to place your component, it's up to you. If you are, and it's also about the application. If, for example, if you want to make this LDR for a security system, for example, you are just placing a laser to this LDR, the circuit will all continuously will show that there is a light. If anyone passes that light, that LDR will show that someone has break down the light between the LDR and the laser. So the light will blink, or if you replace the LED with any buzzer, the buzzer will make noise. So for that, this placement might not be okay. So you can change the placement where you can make it closer to your laser or anything. And there are sometimes the designs are completely up to you. So you can go nuts with your design, or you can organize it properly for your circuit, for your requirement.
Okay, sir. So we have two more questions.
Yes. Can you please show the use of via in case it's impossible to do any specific wire connecting at bottom of part of the board? So the via can be, you have to make another, you can make what you can do, you can do it double layer if it's completely impossible. For example, if you think that this wire should not go from here to here, you just delete this one and I want to go make it here from here, so you can go for double layer, or just place. For that, you need to select the track, change the layer from bottom to top, then go here from here. So now you have a double layer PCB where you have a track on the top and also on the bottom. So it will be expensive in terms of cost, but it will be easier for you to design. But for a smaller circuit like this, I don't think you should go for double layer. And this is the solution where you can change the track, or you can do like place another resistor over here. What you will do is you'll just make it as a jumper, so that you can, or a wire from the top to connect this one to this one without disturbing this line. So you can connect a jumper here to complete this circuit without disturbing this, without causing any cross connection or to this track. The next question is how to get the PDF or IS. I'm going to that. So next part is how will you find the track? I mean, how will you print the layout of the you have just designed? If your design is completed, if you are satisfied with your design and you don't want to make any further changes to your design, what you can do is you can print it out. So for that, you need to select output, then export graphics, and then you have to select in which form you need to make it. You need to print it out. So let's export it into PDF file. Just click export PDF, then this window will pop up. So first of all, what I want you guys to do is select none, not unselect all of the default functions. Then first, what you need to do is you need to select top silk. The top silk are the writings here. The position of the resistors, the blue lines, they will be printed. The reflection of them has to be normal, as in they will appear in the PDF as they are. Change the file name first. Like here we'll like the new PCB be top. This will be the top version. So save, then OK. Just hold on for a second and see. This is the top silk, as in the positioning of the components. You can sometimes some people don't print this one, they just prints out the tracks, and because they know where the positions are. But if it's for someone else, you want to guess the circuit, so he doesn't know the positioning, so then we print out the top silk as well. Then again, go to output, export graphics, select PDF file, then select none. Now you have a copper on the bottom and also on the top. So first, go for the bottom copper. Select bottom copper. Now here is the important part. As this is the bottom part, you can't just print it as it is. You need to mirror it, as in rotate it. For that, you need to select mirror. For bottom part, you need to select mirror. This is very important, because otherwise your circuit won't be printed as you want it. Then change the file name, then write PCB bottom copper. Okay, save. Okay, so this is the track you have designed. These are the holes, the line, see, and as you can see, this one is a mirror of the original version, because as you know, when you flip it, it will be obviously has to be mirrored. Otherwise, you won't be able to get the exact positioning of the tracks. Okay. Next, as we have used a single top copper line here, so we need to output the top copper as well. So again, export file, select none of them, then select top copper, and now the top copper has to be normal because it's not on the bottom, it's on the top. So select normal and change the file name. Here just change it from bottom to top copper, then save it. So this is the top copper line. So by selecting the top copper, you can see there are some extra copper lines here. They are additional ones. If you can just unselect them, as this one has copper on the top and the bottom as well. See, this is a mirror reflection of this one. Now if you want to see the real size of the circuit, just you can see it from here. This is the select 100%, and this is the actual size of your PCB, which after printed out, this will be the actual size of the PCB you have just designed. So we have some complicated PCB designings. Currently I don't have much, but I have one of them I can show you. Yes, this one. So as you can see, this one was a project based on an Arduino and GPS and GSM module. So for that, we didn't had any kind of PCB layout for the Arduino, GPS or GSM module. We knew the pin holes, the place, these distance between the pins and the distance between the components. After that, what we did was, sorry for that. What we did was we placed rails over here and place it exactly with the spacing of an Arduino Nano. Then for the GPS, we needed 4 pin holes. So we placed a 4-pin rail over here to make the positioning for a GPS module. And here for the GSM, we did the same. We required a buck converter over here as well. We did the thing we did for the LED previously. Here we have placed 4 pins, as the buck converter needed 4 pin holes, and placed them accordingly. The sizings were determined by seeing the dimension. What are the dimension between this position and this one? So kind of a complicated but very easy PCB. So let's get back to the questions. So we have a question: what does the rotation part do? The rotation part does is that it rotates your rotation part of what exactly? For the PCB PDF or for the components? You have to be a little bit specific.
PDF file. This one, the rotation, X horizontal and X vertical. I was talking about.
Oh, these rotations. This rotation, you don't have to worry about these rotations. This has to be X horizontal. You don't need X vertical or all at all. They are default sections, and you can make it X. If you do X vertical, then it will appear like this. Okay, just wait. Oh, I have to close this window first. See, it has appeared in vertical. It's just that. If you want it horizontal or vertical, see, everything is in single PDF because you have selected everything. But if you select it like this, none, and just top silk, horizontal means it will show as it is, and vertical it will show in a vertical format. It's up to you what you want to. and the reflection is required. As you can understand, why do we need the reflection part? And don't make it, you have to be careful while reflecting it. You need to know which part you need to reflect. You always have to reflect the bottom parts, not the top cover parts. Here you can see there is a single copper line on the top side. So this one, when you are printing out the top copper, you don't have to mirror it, you just print it out normal. So next, let's go to the next question. Okay, we have to use DC source for providing the power of to the op amp. In case we should use the connect, yes, of course, we forgot to connect the DC wirings. Let me show you. I have once designed one of these, a light detecting circuits for one of my students. So this was a while back I did this design, and the PCB layout was like this. Here you can see I have connected a 2-pin circuit for the power, and in our previous circuit we forgot to give any power connection to the circuit. For that, what I did was I just selected a 2-pin holder, right? Just 2-pin, and then there will be many connections. So then I have selected one of these 2-pin connectors. Be careful while selecting a connecting pin, because you see this spacing is 0.2 millimeter, but the regular spacing of a pins we use, like in the ones are connected in Arduino and Uno, are spaced in 0.1 inch. This one is spaced in 0.79 inch. So you have to find one with 0.1 inch spacing. See, this one has the 0.1 inch spacing. Then I have selected this one, placed it here, and just connected the DC line with number 1 and the ground line with number 2. Now all the ground pins will be connected to the number 2 pin of this socket, and the power line will be connected to this number 1 of this circuit. So that's how, after placing this one, I have connected just the DC, the power where we need the DC power to this one line, and the ground line to this number 2. So we can do is we can attach the batteries ground and positive side with in these 2 holes, and the circuit will be powered. Next question is, in case of what if we select all the components? I have already shown you what will happen if you select all the components. This will happen, and your the shop where you will give this one to print out will get scared. What is this? So this will happen in case you select all of them. You don't need to select all of them. You have to select individually what you need. Okay, thank you. I missed it. Okay, no problem. Any other questions? What is the difference between the output of the component like 7408 and the logic output? I thought both and digital output, but when I'm trying to use the output for the behaviors is not the same. I'm not sure what is the 7408. Is it oh right, sorry, I got it. The output behavior is not same. I'm not sure. It has to be same. If both of them are AND gate or OR gate circuits, then the logistic gate has to work the same. I'm not sure what is the problem with your circuit. In terms of what kind of result you are not getting same. I mean, what kind?
So actually, I was trying to toggle the 7411 output, but when I was trying to using the 7408, I was making the change in 7408 output using some buttons or something like other voltage input, but the output was changing. That like it's coming 0 from 1, but this is also a toggle. but
Right.
this is not giving me a same behavior like when I was using the logic toggle input component of Proteus. But I thought those are same because those are both the toggling and in digital signal, but the behavior was not same for 74121. So can you please help in regarding this problem?
So this problem can be can occur because there are some characteristics of ICs, because the time for the toggle, it might be not the same as you have had in 7408 and the 74121, and both of them didn't had the same, the time duration to make it 0 to 1 and 1
Are
to
you
0.
about the duty cycle of outputs?
Actually, I didn't work with this IC, so I'm not sure currently. I have to look into it to find out what kind of trouble you are getting. Because without visualization, I am actually completely blank over here. When
Yeah, this is a problem.
So
Okay,
I
better.
can.
Thank you.
Okay, and don't worry, I'll get back to you. I'll just have to look into it. Why are they giving different outputs? Any other question regarding designing? And then we'll show you a simple double layer PCB and we'll end it here, because I don't want you guys to go to a higher level designing right now. We'll start with the simple designing and then we'll improve the designing to your level. So are we done? No more questions? So let's just let me show you a double layer one, then we'll just end it. Now, if you can see that these blue lines are our bottom coppers and the red ones are top coppers. You can see bottom copper and top copper. Okay, so I don't want this line to go from here to here. See, there is like a huge copper line required for me to get this line connected to this one. So I don't want this. I want a top copper which will be connected directly to this line. So I just delete this one, select wire. This one is selected as top copper. We'll change the copper line from bottom to top. I'll connect it here. I don't have to go all the way around here to connect it. Next, let's change another one. Like, just change this one as well. Change it from bottom to top. Currently, I don't have any complicated circuits we did back in our days, like our undergrad days. But this is, I want you guys to understand the easiest part. So now you can see that when we go to 3D visualization, so we have copper on top and bottom as well. Let's here, after selecting this, you can remove the components and see only these writings and the copper lines. This is a top copper, this is a top copper, and all of them are bottom copper. And you guys already know how to export the files to the PDF version. Now, what if it's done? Now, what if you want to write your name over here? You want to give credit to yourself that you designed it. So for that, let's just increase the dimension. Now select 2D graphics text mode, the A writing, select it. Then click wherever you want to write your name or anything. Then write the name, like for my name. So, voila, my name is appeared. Now you can change the length and height or the font. Like I want to make it edit properties. I want to change the font. I don't like the font, so I'll I can do this font. I can change the size of the font as well, how big I want my name to be or how small. Then in 3D visualization, voila, it appeared. For any kind of image or any kind of logo you want to make appear in your design or you want to include in your design, you can import any kind of image to your design as well. So for that, these are actually fun things. So for that, you can do is that you can select any logo. I don't have any logo, do I? Yes, I have a logo of IUB. Like, just select this one. So what you will do is you will edit it in paint version, then save it as BMP picture. You can change their colors, like here, let's make it black. This one black, this one also black. Now let's save the file to BMP and save. Yes. Okay. So voila, IUV logo হয়ে গেছে। Now আমি IUV লোগোটা আমার ডিজাইনে appear, I want to make it appear here. So you have to select file, then import bitmap. Then এটা আমার ইসে আছে কিসে ডেস্কটপে। So let's have to go to desktop, logo, IUV logo. Okay, it's a huge logo. You have to reduce the size of the logo. So here we go. Now we have a logo of our university to our design as well. So you can add your own picture if you want to. Just don't add any stuff, it will be complicated. So next question, please. Is it possible to import this Proteus design circuit in Simulink? I haven't done it. I don't think it's possible because in Simulink you need a different type of version, so they don't match actually the circuit designs. You have to separately design it into Simulink because this is basically everything you need to design and make a PCB. Sometimes when you are ordering a PCB, only just giving out the PDF file of the top silk and the bottom copper is enough. But sometimes they want your design as well. So then what you need to do is you have to select all these files where you have saved those files and you need to send it to them. They will then access your file and print it out. Not always the PDF files are enough for you to design to order a PCB. So the designing, again, I'm saying that the placement of your component and whether you want to make it a two-dimensional or a single-dimensional, as in top two-layer or single-layer PCB, it's completely up to you. But if it's a simple circuit, you will always try to go for a single-layer PCB. There are some other things like if like whether it's you know about the dimension of the size. If you making a small circuit but making a big, giving it a very big dimension, it will cost you. It's not that I can make it, why should I go for a small one? If you can afford it, go for a very big circuit if you want to, but it won't look that nice. And yeah, so let's conclude our
Yes, yeah. We have a token of appreciation for you. So it would be presented by the treasurer of IAS IUB Student Branch Center, Faraz Islam. If you're there.
Thank you, Tazor, and thanks to Nazmus Sakib here to give us a valuable time and give us a brief understanding on how to use Proteus and to build a circuit and to make PVC design and how can we print the circuit. It's a great opportunity to have him, and now I will give him a small token of appreciation, and here it is. Thank you.
So So the token of appreciation for the workshop on PCB designing has been handed over to Nazmus for this
Thank
amazing.
you very much.
Okay, thank you everyone. Thank you IAS for organizing this. Inshallah, we'll be meeting soon. Thank you everyone.